Hi guys, in this session I would like to talk about logistic regression. So what is logistic regression? As I explained you in the previous class, one type of machine learning technique is supervised machine learning. So supervised machine learning means in training data you can have a target variable, and that if that target variable is object type or string type, then we'll go for classification. If it is continuous type, we go for regression. So logistic regression is used for classification, not for regression. So when your target variable is target variable's value is like 1 or 0, you mean true or false, yes or no. In that case, you can apply logistic regression. Means it's a binary classification. It can also be used for multi-class problem. Means more than two values. So the main use of logistic regression is predicting the probability of occurrence of an event by fitting data to the logistic function. So logistic function can be defined like this: logit of p, logistic of this p means probability, which is equals to beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 and so on, beta n xn. So beta 0 means its intercept, and beta 1, beta 2, beta 3, beta n, they are the coefficient, and x1, x2, x3 and up to xn, they are the variables from the data set. In other terms, we can say predictors. The target variable can depend on x1, x2, x3 and so on. So these beta 0, beta 1, beta 2, beta 3, they are calculated automatically when you fit your data to the algorithm. So P means the probability of presence, and probability of success is denoted like P, success of P, and opposite to this means 1 minus P, which is failure probability. And we can interpret the result. Once you got the probability value, you can interpret that into 0 or 1. So if the probability value is greater than or equals to 0, we consider that as positive. If it is less than that, we consider that as failure. Or in other terms, we can also set some threshold. So if the probability value is greater than, let's say, 0.5, we can interpret that as 1 or S. If the probability value is less than 0.5, you can interpret that as 0. For example, in order to know whether the customer will buy a product or not, so it's a binary classification problem. So you can fit that data to the logistic function, then the model is built, and that model can give us the predictions if you supply some new data or unseen data. So in terms of graphical representation, linear regression will have a straight linear line that could be either positive or negative, whereas logistic regression, no, in terms of graphs, it is going to be shown as S-shaped curve. Okay, S-shaped curve. In other terms, say we'll say sigmoid curve. I'll show you that. And what are the types? So we have these types: binary logistic function. Logistic regression means the response variable or target variable is having binary, means only two outcomes like good or bad, yes or no. Other type is ordered logistic regression, means there is an order in order maintained, like for example high, medium, low. So if you interchange these values, then meaning will change. And like strongly agree, agree, disagree, strongly disagree. So these values are ordered. So that's why we say ordered logistic regression. And another type is multinomial logistic regression. It is similar to the binary, but the outcomes are more than two. For example, the type of forest, like evergreen forest, deciduous forest, rain forest. So more than two outcomes. So wherever you see the target variable has more than two outcomes, then you can apply multinomial logistic regression. So these are the types of regressions. Here I would like to take an example, that is Titanic survival prediction. So we have a data. Basically, it is an open data. You can get it from multiple open repositories. Even you can get this from Kaggle. So this data set has this description. These are the variables. So I'll explain that about these variables. And there is a target variable survived. So the outcomes are only two: one for yes, zero for no. So by fitting this data to the logistic regression, your model is built, and if you give some new data, then model will make the predictions. So let us build a model. So as I mentioned, it will predict the probability of occurrence of an event by fitting data to the logistic function, or also called as sigmoid function. And you can get the output. You can interpret your results like this. So this is one of the interview question. What is the difference between linear regression and logistic regression? In linear regression, you'll be having a straight line, whereas in logistic regression, you're having a sigmoid curve, S-shaped curve. You can set some threshold value, for example 0.5. If it is greater than that, you can consider that as 1 S. If it is less than 0.5, you can consider that as 0. So types of logistic regression I have already mentioned, and this is the data set, and we need to make a decision. So what factors made the people to sink or survive? And this is the description of the data set. The target variable is survival, 0 for not survived, 1 for survived. And you have P class. P class means ticket class. So there are three types of tickets: first class, second class, third class. And you have gender. Next, age. And SIB-SP means number of siblings or spouses on the board. And PARC means number of parents or children on the board. And there is a ticket number. You have fare as well, and cabin number, and embarked means port of embarkment. Like there are three places: C for Chalkburg, Q for Queenstown, S for Southampton. So as usual, you need to import the required libraries at the beginning. Of course, you can also import them later. If you are not remembered, if you don't know what exactly the libraries you required, so you can also import them later. So in this Jupyter notebook, I would like to import NumPy. So as you know, NumPy is used to create a multi-dimensional array, ND arrays. Pandas are used to create a data frame. You can load the data from CSV file and you can create a data frame. And we want to plot different kinds of graphs. So for that we can use matplotlib, importing matplotlib.pyplot as PLT. So PLT, PD, NP, these are the aliases, means short name. And this is our algorithm, logistic regression, which is imported from the module scikit-learn.linear model. And we want to split the data into training and testing. So for that we can use this train test split. And we'll also use Seaborn for data visualization. And we would like to evaluate the performance of the model. So that's why we are importing metrics from scikit-learn. And sometimes unnecessary warnings comes, so we want to hide them. So import warnings, and warnings.filter warnings ignore. So the warnings are ignored. And I kept my file train.csv in my subfolder data / Titanic1. So the data is loaded from this CSV file, and data frame is created, that is train. So the syntax to load a CSV file is this, using pandas pd.read underscore CSV. Read underscore CSV is the input function. And the next I would like to see the header part of the data. So we can use head of 8. So if you don't give any number here, by default it is going to display first 5 rows. If you give number, then it will display those many rows. So here I gave 8, so these are the first 8 rows. So you can see the first column is passenger ID, survived, ticket class, name is there, gender, age, number of siblings or spouses, number of parents or children, and you also have the ticket number, fare, cabin, and embark means port of embarkment. So there are three values, S, C and Q. So this is the data, and as you can see by just looking at your data through your naked eyes, you can see NaN means missing value, not a number. NaN stands for not a number, so which indicates there is a missing value. So this cabin has missing values. You could also have the missing values in other columns, so we can also check it out. Then here I would like to print the shape. Shape means number of rows and number of columns. So print train dot shape. So you can see 891 rows and 12 columns are there. And I want to see how the data looks. So descriptive statistics. So pandas is providing the function describe. So it describes your data. So by default it describes numerical columns. So these are the numerical columns: passenger ID, survived, P class, A, SIB, SP, PR and fare. And these are the metrics. Count means number of rows, and mean, average value, standard deviation, minimum, 25 percentile data, 50 percentile, 75 percentile and maximum value. As you can see, the maximum age of the passenger is 80 and the minimum age is 0.42, means there is a kid of 4 months. Like also you can check it out, minimum fare is 0 as per this data, and maximum fare is $512, and you can see average fare also this much. So this is descriptive statistics. It will describe your data by applying these measures. And train.info. So info method gives information. Info means information. Importantly, you can know what are your columns and then what are the data types, and finally you can see the summary of data types. So there are two variables which are of float 64-bit, means one is here and the other one is here, and there are 5 columns which are integer 64-bit, and there are 5 columns which are object type, means string type, and the memory consumption is 83.7 plus KB, kilobytes. So this is the information. And so before we'll build a model, we need to do exploratory data analysis. You need to do pre-processing. So as we have checked, there are already missing values. So how do you check missing values? So this is syntax. Train means data frame name, dot is null is a boolean function. It returns true or false, and dot sum means count the missing values. You can see the output. As per the output, 0 means no missing values in the particular column, passenger ID, and in A's you have 177 missing values, and in cabin you have 687 missing values, and in embark 2. Okay, there are 2 missing values. Now you come to know the number of missing values in your data set. Next, this is one of the library, so which you can install missing num by using pip install missing number. Then this library is installed. In my case I have already installed, so I don't want to run this, and I'm importing this. Import missnum as msnum. So this is alias. So the library is imported, and the main use of this library is you can graphically see the missing values. So this is the syntax, missing num dot matrix of train, and you can see the output. There are 3 columns which are having missing values. In A's we already knew that 177 missing values. In cabin many missing values are there, 687. In embark there are only 2 rows, one is here, the other one is here, and black means no missing values. White horizontal line means there is missing value, the particular row has missing value. So that is the use of this library, missing num. And then no machine learning algorithms learns from unique values. So you can say every passenger has unique ID, even name, ticket number. So these variables are not important for us. So that's why I would like to drop. So train is equals to train dot drop. So dropping these columns: passenger ID, name, ticket number. And what do you mean by this? Axis is equals to 1 means these are columns. Remember, axis 0 represents a row, axis 1 represents a column. So these three columns are dropped. And then how to treat missing values. So this is called as missing value treatment, or in other terms we can say imputation. So as we come to know, there are three variables which are having missing values. So I just focus on the first one, age. So I'm having a distribution plot by using Seaborn, SNH dot distribution plot of train of age. So you can see this is the distribution, and by looking at the graph we can see it is having skewness. What type of skewness? It is right skew, because there is a slope towards the right side. So there is a right skew, and if there is a skewness, then how do you impute this particular column? And even as per the studies, so if your column has more than 50% of missing values, in that case better to drop it. If you have the missing values less than 50% of data, then what do you do? Better impute. Now the question comes, how do you impute it? So if your variable or column is numeric type, then you have two options. So either you can impute with mean or you can impute with median. Right now the question comes, when to impute with mean and when to impute with median. If there is no skewness, then you can apply mean, average. If there is skewness, apply median, so that the data is adjusted and it comes to the middle. So you can see here there is a right skewness, so we would like to apply median on A's. Next, two variables are remained which are having missing values. Even you can also know skewness. So train of A's, we are accessing the column A's from the data frame, and skew is the predefined method, so this gives us the skew. So that is positive skew here, 0.38 skewness is there, positive skew, right skew. And in cabin, we already come to know 687 missing values. So we can say almost 77% missing values are that. In that case, better to drop cabin. And next, one more remained variable is embarked. So embarked has only two missing values, and we already checked embarked is object type. Okay, embarked is object types. So if a variable is object type, then you have only one option. You can impute with mode, not with mean or not with median. So you can impute with mode. Mode means the frequency. So I am trying to know the value count, the frequency of embarked values. What are the values? It has three values, S, C, Q. And here you can see S has 644 observation samples, rows. So the mode of embarked is S, because S type is more. So you can impute embarked with S. And also here I am having a count plot, Seaborn dot count plot of embarked. So this also gives the graph. So the frequency of S is more, it is 644, and the frequency of C is 168. The frequency of Q is 77. So count plot presents that on a graph. So we can import embarked with S. So that is what we are doing now. So we are doing imputation. So train dot embarked, you can also access column like this, train dot embarked, accessing the column embarked, and then fill NA, filling missing value. This is predefined method, and filling embarked with S in place is equals to true, means you can have effect after applying. And then A's is filled with median because it has skewness, and cabin is dropped, train dot cabin is dropped, axis equals to months means column. So we have made decisions on these three. Now after imputation, I'm checking the missing values again. Now you don't have missing values, and these are the left out columns: survived, P class, gender, age, CBSP, PORC, fair, embarked. Next we can go for exploration, data exploration, and these are the methods: univariate, bivariate, multivariate. So before that I just want to list out the columns. So train dot columns, these are the columns, and we need to make a decision which features could contribute to a high survival rate. Means we need to find out the relationship between a target variable which is survived with other variables. So at first I'm comparing sex and survival. So I'm doing my own analysis here. So total is equals to, from this gender column, getting the value count, and then this is a variable survived sex is user defined, which is equals to train of survived is equals to 1 means survived, 0 means not survived, getting the value count, and then creating a data frame. So df is equals to pd dot data frame of three variables: total, survived, died, and these are the labels: total, survived, died. This is index, so df dot index, so list of names, and then we are printing data frame as well, and on top of this we are having a bar chart. So df dot plot kind equals to bar, so this will give us the bar chart. So this is your data frame. Two columns are there, male, female, and these are the indices: total, survived, died. So as per this data frame, who are survived more, who are survived more, so females are survived more than males. Who are died more, males died, the female died count is only 81. So this we are showing through the bar chart. So total, survived, died, you can see the legend: blue color for male and female color for female, this orange color for female. So females are survived more. Similarly, we can compare, we can also simply plot a graph by using count plot, but this is less descriptive. So 0 means not survived, 1 means survived, and this is the graph. Then having a relationship between age and survived. So age is numeric type, so we can go for histogram, not a bar chart. So specifying the figure size here, figure size equals to 15,8, 1500 pixels by 800 pixels, and then having a histogram, and we are specifying what is to be plotted on x-axis, y-axis. On x-axis we are plotting age, survived equals to 1, and then survived equals to 0, and for survived I want to have green color, R for red, bins means vertical bars 10, and these are the labels: survived, dead. On x-axis showing the label age, y-axis label is number of passenger, and the legends are also added. So this will give us the figure. So by using this histogram we can see who are survived more and who are dead more. So the people who are having the age between this 25 to 30 survive more, and they dead also more. So finally you can see you need to write a one line description. What are you getting insight from the particular graph? So there is a high probability of survival between age 18 to 30. This is the survival rate. Then having a relationship between the ticket class and survival. Similar kind of analysis here. So getting the people survived in ticket class 1, ticket class 2, ticket class 3, getting the value count for these three classes, and creating a data frame, pd dot data frame of s1, s2, s3, and then I want to have one more variable, total in both columns 0 and 1, and these are the indices: first class, second class, third class, and I would like to rename: 1 means survived, 0 means died, and printing data frame. On top of this we are plotting a kind bar chart, because this variable is string type. So you can see this is the data frame. Who are survived more? The people who are in the class first class people survived more. Who dead more? Third class people dead. and this is the total. For this we are plotting a graph. So first class, second class, third class. You can see the legends here. Blue color survived, the orange is dead, green is total. So who are survived more? Who are survived more? In the first class, the people survived more. This can also be done with one line using count plot. X-axis is survived via comparing survival with ticket class. Data used is train, but this is less descriptive when you compare with the previous figure. Similarly, I'm plotting X on P class on X-axis comparing with survival. So that would be a difference between this graph and this graph. In this graph we are showing survival, whereas in this graph we are showing ticket class on X-axis. So this is more descriptive in three classes: who are survived, who are dead. Then comparison between fair versus survival. So similar to the previous graph A's. So here we are plotting the relationship between fair and survival. And as fair is numeric type, you apply histogram, not bar chart. So survived, not survived, green color, red color, number of bins 10, labels are survived, dead, and then x-axis label is fair, y-axis label is number of passengers, number of people, then showing also the legend. So you can see this is a graph. Who are survived more? Who are survived more? Those who spent less money. The fare is less. Even those who spent some more than $500. So they survived less, and also their frequency is less. So that is why you can see a graph with not much particular count here. Then this is so far this is bivariate analysis, means we are doing the comparison between two variables. And this is an example of multivariate analysis, means more than two. So fair, age, and then survival. So we are having a scatter plot here. Train dot plot dot scatter. You are showing age and fair comparing with survival. Color map uses Z, alpha 0.8, figure size is 8,5. So this shows you the scatter plot. And you can have a color map here. Dark red color means survived, and dark blue color means dead, right? So you almost have equal number of survival and deaths here. And this is bivariate analysis, embarkment compared with survival. So embarked is most object type, so we need to plot a bar chart similar to the above analysis. You can see the data frame here. Who are survived more? 219 from the embarkment S, and dead are also more in S, because the count of S is more people. So the same you can see through the bar chart. In S more more survived, more dead. On the same you can also apply the count plot with single one line of text. So this is the count plot for SCQ. So more are survived in S, then C, then Q. More dead in S. So once you have explored your data, then you can go for data encoding. And at the beginning we have seen there are 5 variables which are object type. And as I mentioned, no machine learning algorithm works with object type of data. So you have to convert them into numeric. So we can use one of the encoder, which is label encoder. So what this label encoder will do, it will encode the values. For example, female can be encoded as 0, male can be encoded as 1. So in the remain columns, these are 2, gender and embarked, which are object type. So remaining columns we have dropped them. So we are converting gender column and embarked. So how do you do that? Importing label encoder from scikit-learn.preprocessing and creating object to the class label encoder, and fitting label encoder, this le dot label encoder dot fit and transform. Which column? Gender column. Then that is assigned to gender column. Then embarked, also converted. So we are converting gender and embarked here. So after conversion, you can have a look of your data frame. So these are the columns which are numeric type. So there is no column with object type of data, string type of data. And now we can go for applying a model. Before that, find out the relationship between the variables. So I'm just listing out the columns again, and then I'm having a correlation. Correlation means finding the relationship between the variable. If one variable is more dependent on another one, then you can have a line, right? You can have a line. uh, I've already explained this. You can have a graph like this. So this is positive correlation. Next, negative means line coming from y-axis to x-axis, and no relation means like horizontal straight line. Horizontal straight line. So finding the correlation, train dot correlation compared with the target variable survived, and I just want to consider the correlation value greater than 0.01. So this is the condition, correlation of this, then that is added to the index of that is assigned to columns, then filtering columns here and sorting the values. Ascending false means descending order. We are displaying the values in descending order. You can see only fair and PR are impacting the survival. The rest of the variables are impacting, but that correlation value is less than 0.001. So these are the top correlated values, top correlated columns. And then having a heat map for these. So plt dot figure, specifying the figure size 8,8, and sns dot heat map. I hope you guys know uh, how to plot a heat map, and you have fundamentals of Seaborn and Matplotlib for data visualization. So these are prerequisites. And plotting train dot correlation, annotation equals to true means uh, the values can also be shown here. Correlation values can be shown, and we are specifying the line width. You can see here, for example, survival. Take a survival column, this one. So which variable has much importance? This fair has 0.26. Okay, 0.26. And one more is this PR, remaining or having negative correlation means no impact. Negative correlation means if one value increases, the other one decreases. So only fair and PR are important. The rest of them are less important. So this is a heat map. Then again listing the columns to just put them into the X. So you can build a model with only these two. For example, let me build a model with only these two. So X is equals to, in X I am putting PR and fair. Then Y means target variable, which is survived. Then building a model here. So using train test split, splitting X and Y, test size 0.2 means 20% test, remaining 80% is considered as training, and it will result as X test, X train, X test, Y train, Y test, random state 42 means randomly seeding the values. Now checking the shape of X train, you have 712 rows, 2 columns, and checking X test dot shape. So same number of rows but 2 columns. So this is a X test, X train means 80% of training data. Now building a model. So we have already imported an algorithm. If you have not imported, you'll be getting an error. So that's why importing algorithm is important. So this is going to be my model name, logistic regression, which is equals to logistic regression of class weight balance. So it means making equal distribution of the class labels and fitting data to the model. Means when you fit the data, the model learns. Model already learned once you have fitted the data. For more information on the algorithm, you can take help. So logistic regression question mark means taking help. So this is a separate help, and you can see what are the different parameters and then what is the meaning of them. So just have a look on this. So my model has already learned. Then once the model is built, making the prediction, logistic regression dot predict of X test, making the prediction for 20% of test data. So its prediction is done, and the predicted values are available in ypredict. If you want, you can also list out what the model has predicted. So you can just add this ypredict in the next cell. So these are the predicted values. Outcomes are only zeros and 1. So once the model is built and made the prediction, you can evaluate your model. So importing classification report from scikit-learn.metrics and having a classification report between y-test means actual and y-predict means what the model has predicted. If there is a difference between actual and predicted, then we'll say error. So as per the classification report, the accuracy is 67%. Accuracy is 67%. And you can also see the other metrics like precision, recall, F1 score. So F1 score is the harmonic mean of precision and recall. So we see F1 score value better. So 74%. Here is 54%. And these are the number of samples supporting classification 0, 105. 74 samples classified into class 1. So the final accuracy is 67%. And you can make the prediction. So this is sample value. I'm giving these parameters. So P class, ticket class 1, gender 0 means female. This age value C base P. So these parameters are supplied and we are using our model. Then model will make the prediction. So I think we have not used, so we took only 2 variables. So that is why these variables are not recognized. I'll show you that. So we got the accuracy 67%. Now let us take the variables. This one x equals to, let's take all variables, P class, gender, age, C base P, all variables. So this is my x and y, and splitting this into 20% testing, 80% training. Now checking the shape, same number of rows, but the columns have been increased now, 7. Now building a model, making the prediction for x test, showing the predicted value. So these are the model predictions, and looking at the classification report when you consider all. Now the accuracy has been increased. So more model, more data, more learning. So as you have increased the number of features, the accuracy has been increased. So you can also check F1 score and recall value also better here. Accuracy 82. Now if I give all these, then the model will make the prediction. As you can see, the model has classified this unknown sample as 1. 1 means survived, 0 means not survived. Got it? So this is the output. So we have successfully built a logistic regression model for survival. Survival, right? So like this, you can build a logistic regression model. I hope you guys have understood, and if you have any queries, you can also reach out to me, and do subscribe our channel so that you can get updates on new videos.